Okay, so let's just go back. So what you've got here is just the filled in notes from what we did yesterday. So I figured let's just review because it's amazing how much we forget on a weekend. So what are odds? So it depends on whether the question says odds in favor or odds against. So if it says odds in favor, it's typically written as a ratio. So it's typically written like with that colon sign. So when it says odds in favor, the first number you'll see is the number of favorable outcomes. The second number you'll see is the number of unfavorable outcomes. And if you add those together, you get the total number of outcomes. Okay? For odds against, the first number you will see is the unfavorable number, and the second number you see is the favorable number. Again, if you add them up, you will get the total. Now, how this compares to probability. So for probability, it's the number of favorable over the total number. Whereas odds is number of favorable to number of unfavorable, or number of unfavorable to number of favorable. It's that, okay, how does kids screw this up? They understand that the first number matches the words, but in odds, the second number is not the total, the second number is the opposite happening. But when you add those two numbers, so this total here is this total here. So you've got to read the question super careful to make sure that the question says, what's the probability or what are the odds? Because they mean something different. Okay. So we already did a couple examples on this. So I put one of those examples on the next slide. I'm not going to go through it again just because we already did it. Where we were at in the book was example number 5. Okay, so it's on the bottom of page 132 is where we're at. So it says, when placing bets on horse races, by the way, it's kind of illegal, so don't gamble. Well, it's legal if you're over 18. When placing bets on horse races, the chance that each horse will win are often quoted as odds. In a particular 5-horse race, the odds against each horse winning. So make sure you read, okay, odds against. So what that means is the first number you see is the unfavorable. The second number you see is the favorable. So Free Spirit has 2-to-1 odds. So there it's 2 times, so it's gonna lose 2 times for every 1 win. So this is the loss, this is the win, right? Because odds against would be losing, right? Willow it's going to have 3 losses for every 1 win. Foxtrot will have 7 losses for every 2 wins. Gloria will have 8 losses for every 1 win. And Lucky Joe will have 11 losses for every 1 win. He's not so lucky, okay? So it's loss to win. Which horse is the favorite to win the race? So, how would we do this? So what I would do is I would actually go to probability, because probability shows their percents of winning, right? So probability that they win the race. So Free Spirit. So what is the number of favorables for Free Spirit? So winning the race. So this number here, the winning the race, the win number is that one right here. That's the win number. So the win is 1 out of, now what's the total? So if you add 2 plus 1, 3. So Free Spirit has about a 33% chance of winning. I find probability easier to understand than odds. But that's me and my cup of tea. That doesn't mean it has to be yours. If we go through the list now, so the probability that Willow wins is 1 out of 4. So he has a 25% chance of winning. Foxtrot is 2 out of 9, which is 22% chance of winning. And how I'm getting those percents is I'm just going on my calculator, 2 divided by 9, 1 divided by 3, 1 divided by 4. Gloria is 1 out of 9, which is about an 11% chance. And Lucky Joe is 1 out of 12, which is not a clue. Not very high. Is 8%. So if we go back to part A now, which horse is the favorite to win? Free Spirit. Because he has a 33% chance of winning the race. And if you look at the numbers, this one's going to lose 11 times for every one win. This one should only lose twice for every one win. So it's got the best odds. Okay, but sometimes it's hard to see until you break it down into their percents. And I find the percents just way easier. So again, what is meant by the phrase odds 2 to 1 against? So against means the first number you see is the unfavorable. Second number you see is the favorable. So unfavorable in this question would be a loss, where favorable would be a win. So in other words, they're going to lose 2 times for every 1 win. So every 3 races, you expect that horse to lose 2 and win 1. Okay. Now I know it's not, I had some kids in the last semester, they just understood odds. They didn't need to convert everything to probabilities. That's fine. Honestly, I've always understood odds, but I've never really mathematically played with them. Whereas probability, I'm much more familiar with. I think that's why I convert everything to probability, just because that's more my happy place. So, okay, determine the sum of the probabilities. So if we were to add up all of these, so 33%, 25%, 22%, 11%, and 8%. It ends up being about 100%. Does that make sense? If there's only 5 horses in the race, does one of them have to win? Yes. So if you add up each of their probabilities, they have to add up to 100% because there's only 5 horses in the race. Okay, so the chances of each one of them winning, this is the chance of each one of them winning. So one of them has to win. So that's why they have to add up. Remember, that's the universal set. Okay. What are the odds in favor of Foxtrot winning the race? So this is super easy. So Foxtrot, odds against are 7 to 2. So what are the odds for? What would they be? 2 to 7. You just switch up and around. Because remember, the first number has to match. So odds against, so the first number has to be the against. Odds in favor, the first number has to be the favor, or the favorable. So you just swap the numbers around. So on this one, the probability of losing is 7 over 9. On this one, the probability of winning is 2 out of 9. And I know it's very warm in here. I can't get it to turn off. So it's a matter of reading each of these questions really carefully. Just remember the first number you see is the number that matches what the question is asking. The second number you see is the opposite of that happening. Okay. Okay, so let's just do a few questions on the assignment and then we'll go from there. So make sure on the assignment that you take out number 10. Don't do that one for sure. But let's go to number 4 together. So it says, in baseball, batting averages are decimals between 0 and 1, which represent the relationship between the number of hits and the number of at-bats. Jose, Brett, and Edwin, players on a minor league team, have the following batting averages. So Jose is 0.25. What's the next one? Brett is 0.310. And the last dude is 0.275 for Edwin. So the question said, if we go back, it says number of hits. It's a relationship between number of hits and number of at-bats. Okay. So it says, in terms of probability theory, what does a batting average represent? Well, essentially, it's their percent. Like, he's going to hit 25% of the time. He's going to hit 31% of the time, and he's going to hit 27.5% of the time. Just think of it like this. If I write it as a ratio, you put 1 as the second number. If I wanted to convert this to a decimal, it would be 0.25 over 1 or 25 over 100, which is 25%. So it just represents the number of times that they're going to, that they should hit. So Jose should hit the ball 25% of the time that he goes to bat. So in other words, every 4 times he goes to bat, he should hit 1 time. I don't think that's very good, but whatever. I suck at all sports. Okay, so if Brett has been up to bat 210 times this season, how many hits did he get? So Brett, he's been at bat 210 times, and he's expected to hit 0.31 of those times, or 31%. So you just think of it as that timesing it by 31%. Or in other words, 210 times 0.31. And then just round it to a whole number because you can't have partial batting. And you should get out, so 65 times. So out of the 210 times he's gone to bat, he should hit 65 times. Okay, so here's what we've been talking about. What are the odds in favor of Josie getting a hit? Jose. So odds in favor. So the first number that we see is hit. Second number we see is miss. They have to add up to give our total. Our total is 1, right? Because you either hit or you miss. So those two numbers have to add up to give 1 or 100%. So Jose hits 0.25 of the time, or 25% of the time, which means he misses how much? 75. So you can leave it like that. Usually on the diploma though, what they will do, sorry, I didn't mean to hit that. On the diploma, they will simplify this down. So all you have to do on your calculator is go 0.25 divided by 0.75, math 1, and convert it to a fraction, and you should get out 1/3. So that's how they will usually give it, is they will reduce down those decimals. So what does that mean? He's going to, for every 1 hit, he's going to have 3 misses. That's what that means. Okay, for every 1 hit, he's going to have 3 misses. because remember his probability of hitting was 1 out of 4, which is 25%. 1 plus 3 is 4. Okay. What are the odds against Edwin getting a hit? So odds against Edwin. So the first number we want to see is if it's against hitting. So the first number we want to see is the miss. The second number we want to see is the hit. Again, they have to add to give 1 or 100%, however you want to define it. So what was Edwin at? Edwin was 0.275. That was his hit number. So how would you figure out the miss? What's the easiest way to do it on your calculator? Just go 1 minus 0.275. You get out 0.725. So again, you can leave it like that, but the diploma will probably reduce it down. So on your calculator, go 0.725 divided by 0.275, and then go math 1. So you get 29 to 11. And so he's going to miss 29 times. He's going to hit 11 times. 29. So in other words, for every 40 times at bat, he's going to miss 29 and hit 11. So again, how I got there, on my calculator, I went 0.725 divided by 0.275, and then I went math number 1. Okay. So again, it's just reading these very carefully. What you want to do is you want to express it in a way that makes sense to you and then try to match it up after the fact. Okay. Let's look at number 15. Whew. It's warm in here, right? It was beautiful this morning in here. And I left for lunch, came back, and now it's horrible. Oh, lovely. Oh, okay. Okay, 15. Recent stats show that on a particular lake, 13 in every 50 boating accidents are due to the pilot being distracted. Pilot? Pilot of a boat? Driver? Captain? Anyway, whatever. Whatever. The odds that a boating accident is due to the pilot being distracted can be written in the form. Okay, so odds due to distracted. So that means the first number you see is the distracted. The second number is not distracted. Okay, so distracted to not distracted. And they have to add up to give you the total. So 13 in every 50 boating accidents are due to the pilot being distracted. So number of favorable is 13. The total is 50. So how many then are not distracted? 37. Now take a look at the bottom of your page. You can see the way they wrote the numeric response is 1337. So 1337. Okay, because knowing how to fill in numeric response is important. Okay. So that's a perfectly good diploma exam style question. Okay. Let's go back to number 13. So it says, using data from over 50 years, the odds of a baby born in Newton being a boy, I'm assuming Newton is a town. Newtown. Oh, Newtown, not Newton. Oh my. Whew. The odds of a baby being born in Newtown being a boy are 23 to 27 in favor. So what were the numbers again? So odds in favor of being a boy. So what does this first number represent? Boy. What's the second number represent? Girls, or essentially not boys, right? And we're going to assume babies are either male or female when born, right? We're not going to get into that whole, we're not going to go down, we're not going to politicize this, okay? So then the total is 20, 40 is 50, okay? And if you read the question, over 50 years, over 50 years, there's 50 pieces of data, right? So, okay. Using this data, the probability that the next baby is a girl. Okay, so you want the number of girl over the total number, right? The number of favorable over total. So what's the number of girls? 27 over 50. So again, you could leave the answer like that. You could punch in your calculator and make it into a decimal, or you can make it into a percent. It depends on how they want it written. What did they ask for on this one? There was hundredths, so how many decimal places is that? So again, numeric response, you have to put the 0 in. So it's 0.54. So one thing for each blank. Okay, let's look at number 14. When 2 dice are rolled, the odds of throwing a double are 5 to 1 against. So odds against getting a double are 5 to 1. Okay, so what does that 5 represent? Right, so this is getting a single. This would be getting a double. You're also welcome to say getting a double, not getting a double, right? You can word it that way too. I don't like knots. Remember I talked to you guys about that in the last unit. They just don't make sense to my brain. So I will typically think of what not means and write it that way. Okay. If 2 dice are rolled 300 times, the best estimate of the number of doubles that would be expected. Okay, so we need to figure out the probability of getting doubles. So it's going to be what over what? Probability of getting doubles is 1 out of 6, right? Because remember, it's total. And if it's rolled 300 times, you just go 1/6 times 300, and you should get out 50. So on 300 rolls, you should expect 50 of them to be doubles. Now, does that mean you are going to get 50 that are doubles? No, it just means that theoretically you should get around 50. Okay. That's it. That's all.